Now that we have the parser and we can transform program text into an abstract syntax tree, we have to figure out how to build the evaluator, which takes that abstract syntax tree and evaluates it. And for arithmetic expressions, evaluating it means that we need to get the numeric value result of that expression. And so let's go ahead and look at the code in the assignment for the evaluation function. So the evaluation function is in this file called simplecalc.hs, and it's pretty simple. So we import the parser module that I showed you in the last video, and then we call this function readLines, which for each line that the user types in, we pass that line to this evaluation function, or function called evalPrint, which takes the line, does something with it, and prints the result. And all it does with it is it calls parseCalcExpr, which is the function that we had defined in the parser, on that input line that the user typed. And then prints the result of calling eval on that expression. And the expression in this case is going to be the abstract syntax tree. So the eval function is pretty straightforward here. It has one case for each case in the calcExpr abstract data type. So if we have a number, n, it evaluates to n. If we want to negate n, that evaluates to the negation of the evaluation of n. And you can see that these rules are basically the same rules that we had in the operational semantics, where it says that in order to evaluate some compound expression, like sum, we have to first evaluate the two subtrees, and then apply the operation to get our value for this tree vertex. And the only thing here that's a little bit weird is that instead of using slash as the division operator, we call this div function, and we put it in backticks to show that it's an infix operator. And this is just what Haskell calls integer division. The slash is used for floating point division. And so this is pretty much as simple as we can get.